This unit really focuses on some building blocks of geometry, different figures, and what we call them specifically, because some of them are referred to a little bit differently than what you would in everyday life. Points, I think we're pretty familiar with. A point is an exact location in a plane, right? Kind of just like your dots. What I think gets tricky from there is we kind of use the word line to mean a lot of different things, but a line is a collection of points that continues on in both directions forever. So what's important for a line is that it has these arrows, or say it goes all the way through whatever image, and then we're to assume that it continues on forever. A line segment is like if we take, let's say that's the line, but I just want this portion here. It should have two endpoints. Those are the endpoints, literally points on the end. So that segment separate from the full line would just look like that. And then we have a ray, which is, again, a portion of a line, but it just has one endpoint and then goes on forever in one direction. So again, a point is an exact location. So point A should just be by itself, just a point out there. And then looking at the difference between line segment, and ray AB, we need to see, does it have endpoints? How many endpoints does it have? In which directions does it go on forever if it does? So I will say if we can see one with two endpoints, we know it's our line segment. And I see this one down here, no arrows. It has two endpoints. Line segment AB is on the bottom. The one all the way to the top has an endpoint at A and then looks like it continues on in one direction forever. So that is our ray AB. And then it should be that the third one is line AB, but just to confirm, although I see points on there, it looks like it continues on in both directions forever, which is true of a line. Naming points is pretty simple. In this image, right, the first one I see is point A. We would just call that. It's just A. When I refer to A, I know I'm going to this point here. Lines need 2 points. So it has to be 2 points that are on that line. And then we just draw what looks like a line symbol above it. So there's line AB is right here, and we're to assume that it continues on forever. I can also call it line BA if I want. So there are two other lines in this image that you should be able to grab and name. And then make sure it has the right, what's called notation. Above it should be this little arrow and then, whatever letters. Moving into segments, again, naming it with 2 points, but it needs to be its endpoints. So I say there's a segment AB in this image, and it happens to be right here. And it gets basically a little segment on top. You don't have to put the dots on the end, just kind of like a dash. There are so many different segments in here. So I'll point out on one specific example. Like right here, there are many different segments. There's this segment, AD. There's this part of it, which is D to F. And there's also the full segment whose endpoints are A and F. So there's also a segment AF. Right, so there is a lot you can grab from this image. But just grab an additional 3 segments that are in there. rays get named again by 2 points, but it starts with its end point, and there's just another point. And then above it, its notation, it gets what looks like a ray. Well, it goes on in one direction. So there is ray AB in this image. I could not call it ray BA because B would have to be the endpoint, and it's not. There is no ray BA. But there is this ray AB. So there's 2 additional rays in this image that you should be able to identify. Putting some of those pieces together brings us to angles. So an angle is actually composed of 2 rays that happen to meet at this same endpoint. So in this case, we have ray BA and ray BC. They meet at B to form this angle. And there's a few different things we can name this angle. The gist of how to do so is you want it to trace the shape. So I have to go down and over. That works. Well, if I start from here, I hit A first, then B, and then as I go over this way, C. A, B, C traces the angle. But I could also trace the opposite way. In here and then up. Well, if I come from that direction, I go C, B, and then up to A. So C, B, A is also an option. I'm not going to be able to do something like BAC. Because if I did that, okay, start at B, go to A, go to C. Oh, well, that's not the same. Or something like BCA, BCA. That also doesn't look like it. So just be careful. And then again, you can always just double check afterwards. Does it trace? Well, let me start here. I need to go A to B to C, A to B to C. That looks good. There's many different types of angles. We call them certain things based on their size, how big they are. Starting with something that's the smallest would be acute. An acute angle is an angle that measures less than 90 degrees. So one of our references is 90 degrees, which is called our right angle. But it looks, essentially forms like a corner, like a perfect corner. Anything thinner than that is an acute angle. So even if it just goes like a little bit or a lot of bit, those are all examples of acute angles. But we know that their measures need to be less than 90. So we've got things like 20 degrees. 20 degrees is less than 90. 87 degrees is less than 90. 89 degrees is less than 90. 89.5 degrees is less than 90. Any value that is under 90, but greater than 0, of course, is an acute angle. And then we have that frame of reference that is a special angle called a right angle. If it is exactly 90 degrees, it's a right angle. If it's 91 degrees, not a right angle. 89 degrees, not a right angle. It has to be exactly 90 degrees. Then from that frame of reference, we go, okay, well, we went smaller, we hit 90, and now we're going to go a little bit bigger this way. And we have what are called obtuse angles. So it doesn't have to be much bigger, but it does need to be bigger than 90. So things like 91, 100, 150, 170, those are all obtuse angles up until we hit what's called a straight angle, which is named based on its look. It's essentially a straight line. but we're referencing the space in between the rays where they meet. This is 180 degrees. If it's exactly 180 degrees, it is a straight angle. If it's 181, not a straight angle. 179, not a straight angle. And then remembering, so obtuse is not only bigger than 90 degrees, but it has to be less than this 180. So anything in between those two values is an obtuse angle, like that 123, 91, 170. So as you name these or classify them as acute, right, obtuse, or straight, just be thinking, which does it work with? Not seeing them, but just based on their measure. A 10-degree angle is definitely not 90 degrees, so it's not a right angle. It's not 180 degrees, so it's not a straight angle. And then is it less than 90 or between 90 and 180? And you see that it's less than 90, so 10 degrees is an acute angle. You would just use a similar process to that for the remaining values. But we can also start to recognize patterns in what they look like, so we can kind of estimate their size and tell if it's acute, right, obtuse, or straight. Acute angles, again, it's just anything less than 90 degrees. They're these little guys. Right angles, if you know something's a right angle, this little box in the corner is a way for you to verify that for yourself. We only put those boxes in the corners of right angles. Those are exactly 90 degrees. Then we have obtuse angles, which again, if our 90 is like kind of in here, I see that it's a bit bigger than that. All the way until we get what looks like a straight line, which is our straight angle at 180 degrees. So I think kind of the easiest ones to point out are like, is it 180 degrees? Is it 90 degrees? And of the three that are shown here, I know that number 2 is 180 degrees and is a straight angle, right? That's just a line. That's straight. And then coincidentally, there's not an example of the 90 degrees here, so I will draw that over here as our frame of reference. This would be a right angle. So then looking at the two that remain, one of them is bigger and one of them is smaller. Number 1 is smaller than the right angle, so it is acute. And number 3 is bigger than the right angle, making it obtuse. Adjacent angles are angles that are next to each other. They share a common ray. So if I'm looking in this first image, it looks like there's a lot going on. But at the core, I see an angle XWY right next to YWZ. And they both share ray WY. Now, if I know the measure of both of those angles, I can add their measures to get the measure of what is the larger angle that they're making together. So even though there's this little XWY, YWZ, all together they make this larger angle XWZ, or as they write ZWX. So if I know piece, I can get the whole by adding those together. One of the pieces is 74. Another piece is 66. And if I add those together, I should get 140 degrees. Just like that, addition and subtraction are very related to each other. If we know the whole angle and we know one of the pieces, we can subtract them to find the measure of what is missing. right? I know big angle is 58, and that is my small angle 19 plus what I don't know. And then in a one-step equation to get rid of the 19, it's being added, it's positive 19, we're going to subtract it from both sides. That's where you see the subtraction come in. And our missing angle ends up being 39 degrees. Now there are two very special adjacent angle relationships, one of which is complementary angles. Complementary angles are angles that add to 90 degrees. I know that they form a right angle. I know that these two angles add to 90. 30 and x. Again, to get rid of that 30, just a one-step equation, subtract the 30 from both sides. Well, I know x has to be 60. 30 plus 60 is 90 degrees. That forms that right angle. Same thing over here. I know the larger angle is 90. That's x, which is this angle here, plus this other angle, 63. Subtract from both sides. And you get your value of x. This is as opposed to supplementary angles, which are, again, it's an adjacent angle pair, but these add up to another special number, the 180. Together, they form a straight angle. Right, the total is 180. Well, the pieces are 77 and x. Subtract your 77. And you would do the same on the other side. There's a lot of vocabulary in this unit. Again, it's sort of just the foundational pieces. Like in algebra, you would have had to learn coefficient, constant, variable, term, those kinds of words before other topics made sense. That's kind of what happens here. We have a lot going with the points and the rays and the angles, just kind of get into the core of angles and how they relate to each other, the pairs that they make, those complementary and supplementary angles.